The following video will show several sling configurations using the same rigid load, with accompanying load cells to display each sling's tension. Let's see what really happens to the loading of each sling as they are subjected to an erratic load. The following test shows a 4-leg alloy chain sling hookup with all 4 legs supporting the load. Sling number 3 showed the highest increase in loading at 16%. The hoist supporting the load increased by 4%. The following test shows a 4-leg alloy chain sling hookup with only 2 legs supporting the load. Slings 2 and 4 show an increase in loading at 4%. The hoist supporting the load increased by 4% as well. The following test shows a 3-leg alloy chain sling hookup with all 3 legs supporting the load. Sling 1 is supporting half the load and slings 2 and 3 are sharing the other half of the load. Slings 2 and 3 showed the highest increase in loading at 9%. The hoist supporting the load increased by 4%. The following test shows a 4-leg wire rope sling hookup with all 4 legs supporting the load. Sling 4 showed the highest increase in loading at 8%. The hoist supporting the load increased by 5%. The following test shows 4-wire rope legs sharing the load, one inverted basket hitch with 2 vertical hitches. Legs 1 and 3 showed the highest increase in loading at 13%. The hoist supporting the load increased by 7%. The following test shows a 4-leg synthetic adjustable sling hookup with all 4 legs supporting the load. Sling 1 showed the highest increase in loading at 8%. The hoist supporting the load increased by 4%. What we learned from these tests. When all sling legs are loaded, they stay loaded. When only 2 slings are carrying the load, the other 2 slings stay unloaded. Sling loading increase is due to dynamic load, not share of load. Share of load changes only when the center of gravity distance changes from the attachment points. The horizontal load force created by the sling angle prevents load share change or slacking of the sling. An inverted basket hitch will not adjust unless the D-to-D ratio at the hook is large enough and the load is heavy enough to cause the sling to adjust.